Hi everyone, it's Mrs. Griffin with the Unit 3 Lesson 12 video. We're going to be talking about point reflection. So when we do a point reflection, it is something that exists when you have a figure built around a single point called the center or point of reflection. And what happens is for every point in the original figure, there's going to be another one found directly opposite on the other side of the center, so that that point of reflection, that center point, becomes the midpoint of the segment joining it and the figures and its image. So under a point reflection, figures don't change size and shape. So if we look at example 1, I have it graphed here, triangle ABC, and we're going to do a reflection in the origin. The origin is 0, 0. I have that put in red. And so what we're going to do is we're going to look at A and the origin as a portion of a segment. And we're going to imagine that this segment is going to extend and then continue further the same amount so that the origin is the midpoint. So we treat this just like we did midpoint back when we did the midpoint. So A to the origin, it's 1, 2, 3, 4, 1. So you would have to go down 4 and left 1 to get from A to the origin. If we did that again, down 2, 3, 4, and left 1 again, this point here is A prime. And if you were to imagine connecting A to A prime, we're not going to leave this here, but the origin would be the center of that line segment. It would be the midpoint. Okay, we're going to continue and do point B the same way. Again, remember our center is the origin. So for point B, to get from B to the origin, you have to go down 1 and left 1. If we do that again, we now have B prime. And the same with C. To get from C to the origin, we're going down 1 and left 2, 3, 4, 5. So down 1, left 2, 3, 4, 5, and C prime would be here. This would be our new triangle, which had been reflected through the origin. So again, imagine connecting A to A prime, B to B prime, and C to C prime. You can see that that middle point, that origin, is our center of all of those. Additionally, it's 180 degrees of a rotation if you were to imagine measuring from the center to A and then flipping it around. It's a perfect 180 along that line, and that's how point reflection really does work. All right, on to number 2. We have this quadrilateral graph, and again, we're going to be reflecting through the origin, so we're going to count from each of these points to the origin. So to get from L to the origin, we'd have to go down 2, 3, 4, 5, right 2, 3, 4, 5, 6, 7, down 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And so you're just repeating your count again so that your center of reflection is your midpoint. Same thing for M. It's down 2, 3, 4, 5, and right 1. Down 2, 3, 4, 5, and right 1. N is right 2 and down 1, right 2 and down 1. And O is right 3 and down 1, so right 3 and down 1 for O prime. There is our new one. It does say here that we're supposed to state the coordinates of L prime, M prime, N prime, and O prime. When we do that, maybe you'll notice a pattern. For L prime, 1, 2, 3, 4, 5, 6, 7, negative 5. For M prime, it's 1, negative 5. For N prime, it's 2, negative 1. And for O prime, it's 3, negative 1. If you compare those with the original points, you can see that each one of my originals, the signs have just been switched. So whatever it was, it became the opposite sign. This is a special shortcut rule for reflection in the origin only. Okay, so it is a nice rule to help us. All right, now, in this particular example, we have a point A, and the point that we're going to reflect it through is a different point than the origin. It's not the origin this time, it's 2, 3. And so if you can remember what I said about this being the midpoint, we have A, we need to find the A on the other side. So we're counting to get from A to our center of reflection. So it's down 1 and over 2, 3, 4. Repeat that, down 1 and over 2, 3, 4. And that will get you A prime. And that coordinate would be 1, 2, 3, 4, 5, 6, 2. And this is another way of finding endpoints with midpoint if you ever wanted to. We do the same thing for number 4. We have our point -6, -2. And the reflection point is -3, 1. So to find the A prime, we're going to go from A up to 3 over 2, 3, and repeat up to 3 over 2, 3, and that will be A prime again, noticing that the reflection point is the midpoint of the segment, or the segment that's not really drawn, the imaginary one between A and A prime. And A prime is 0, 1, 2, 3, 4. For number 5, this time they're giving you A is 6, 5. And A prime is -2, 3. And this time they want the coordinates of the point of reflection. So we need to find the center of reflection. We need to find the midpoint. So you can do this several ways. You can do your midpoint formula, where you're averaging your x's and averaging your y's. And you would get 4 divided by 2, which is 2, and 8 divided by 2, which is 4. Or you could count how far it takes. It's down 2 over 2, 3, 4, 5, 6, 7, 8. Down 2, left 8 to get from A to A prime. And then you're just going to cut that in half and only go down 1, 1, 2, 3, 4. Either way, you're still going to get your coordinates as 2, 4. Okay, now point symmetry is also known as 180-degree rotational symmetry. If a point can be flipped 180, can be rotated 180 and still appear the same as it was before, then it has rotational point symmetry. If I look at the letters in this choice here and I turn the entire thing upside down, which letter doesn't appear to be upside down? Which letter looks the same right side up as it does upside down? That letter is H, and that's the one that has point symmetry. So it is choice A, because it looks the same when rotated 180 degrees as it did originally. Okay, I will see you in class.